Hello everyone, and welcome. Today, we're going to demystify a concept from thermodynamics that can seem a bit strange at first: fugacity. Have you ever wondered why the simple ideal gas laws we learn in basic chemistry don't always work in the real world? Fugacity is the key to understanding why. To get started, let's remember the ideal gas. In an ideal gas, molecules are treated as tiny points with no volume, and they don't interact with each other. They just bounce around. For these gases, pressure is a perfect measure of their tendency to escape or expand from a system. It's simple and straightforward. However, real gases are more complicated. When you increase the pressure or lower the temperature, real gas molecules get squeezed closer together. They start to feel intermolecular forces. They attract each other and they repel each other. These interactions change how the gas behaves. The actual pressure you measure with a gauge no longer accurately represents the gas's true escaping tendency. This is the problem that fugacity solves. It was introduced by the brilliant chemist G.N. Lewis as a sort of thermodynamic patch. He proposed creating an effective pressure, which we call fugacity. This fugacity is a property that allows us to use the simple, elegant equations designed for ideal gases to accurately describe messy, complicated real gases. You just swap the pressure term, P, with the fugacity term, F. Think of it like social pressure. In an empty room, you feel no pressure to leave. This is like an ideal gas at low pressure. Now imagine that room is packed. The physical pressure is high. But if those people are your best friends, your desire to leave might be very low, even lower than the crowding suggests. The attractive forces keep you there. Conversely, if the room is full of your rivals, your desire to escape would be extremely high, more than the physical crowding would imply. Fugacity is like this social pressure for molecules. It accounts for the attractive and repulsive forces, giving us the true measure of their tendency to escape. For an ideal gas, the fugacity is exactly equal to its pressure. For real gases, we use a correction factor called the fugacity coefficient to relate fugacity to pressure. If this coefficient is less than 1, attractive forces are dominant. If it's greater than 1, repulsive forces are in control. In essence, fugacity is the pressure a real gas would have if it were to behave as an ideal gas while still having the same chemical potential. It's a fundamental concept for accurately predicting chemical reaction equilibria and phase transitions, especially in high-pressure industrial processes. So, fugacity isn't just a random term, it's the corrected pressure that makes our thermodynamic models work for the real world. I hope this explanation made the concept of fugacity a bit clearer for you. Thank you so much for watching. If this video helped you out, please give it a thumbs up and consider subscribing to the channel. Your support allows us to keep making more educational content. See you next time.